The angle between vectors is something we calculate using the dot product to give us the angle between two vectors. So what we're using here is we have a very specific formula that allows you to find the smallest possible angle that you can form. Usually we're talking about angles between 0 and pi, in other words 0 and 180 degrees. However, a lot of what we're doing with vectors, you're usually going to start off in potentially in a radian type measure. Okay, so here our formula says that the cosine of your angle should end up being the dot product, so u dot v, over the magnitude of each, so the magnitude of u and the magnitude of v. Okay, so we're going to take the dot product of the two vectors and we're going to multiply on the bottom the magnitude of the two vectors. So there's a lot of individual calculation that has to go into this before you end up plugging it into the actual equation itself. The best way to explain it, like always, is to use an example. So here the question says to find the angle between the given vectors to the nearest tenth of a degree. So because we're talking about degrees, you want to make sure that your graphing calculator is set to degree mode because we want tenth of a degree here. So we're told that we have vector u has the linear combination 3i plus 2j, and vector v has the combination negative I plus 4j. So let's go ahead and look at u. So u, again, we were told was 3i plus 2j. Well, in terms of a component, that's going to be 3, 2. With that, we can find the magnitude. So the magnitude of u is going to be the square root of 3 squared plus 2 squared. So this is going to be 9 plus 4, which is the square root of 13. Okay, so that is u. Now the other piece that we have is we have v. So v was going to be negative I plus 4j. So in component form, that's negative 1 and 4. Again, to find its magnitude is going to be the square root of negative 1 squared plus 4 squared, which is going to be the square root of 17. 4 squared is 16, 1 squared is 1, add them together you get 17. So those are all the pieces that we need to work with. Now the next thing that we need to do is we need to remember the formula. The cosine of my angle is going to be the dot product, so u dot v over the multiplication of your magnitudes. So let's first fill in the information we have. So this is going to be 3, 2, dot product with negative 1, 4. And this is going to be over the square root of 13 times the square root of 17. So you see, as long as you do your individual pieces first, it makes the next step very, very easy because all you're going to do is plug and chug. Alright, so with this, we need to go ahead and find the dot product. So across the top, you are going to have 3 times negative 1 plus 2 times 4. And then we've got the multiplication on the bottom, 13 times 17 is going to be 221. So when we look across the top, we have 3 times negative 1, which is going to be negative 3. 2 times 4 is 6. So we have negative 3 sorry, 2 times 4 is 8. Negative 3 plus 8 is going to be 5. I think I need some more coffee. So we're going to have 5 over the square root of 221. Now we have to remember this equals the cosine of my angle. So to find my angle, says I have to take that inverse cosine of 5 over the square root of 221. So my angle here is going to be 70.3 degrees. Okay, so remember, make sure that your calculator, a graphing calculator that you have, is set to degree mode, and then all you simply have to do is plug your information in and solve. Alright, let's look at another equation or another example of how you might see some of this written. So here we want you to round to the nearest hundredth, and we are told that u is going to be the cosine of pi over 4 I plus the sine of pi over 4 j, and v is the cosine of 5 pi over 6 I plus 5 pi over 6 j. So we have to be able to go to component forms. So first thing we need to look at is, let's go ahead and look at my u. U is going to be that cosine of pi over 4 I plus that sine of pi over 4 j. So when we look at the cosine of pi over 4, this is going to end up being square root of 2 over 2. Well, that just so happens to also be the sine of pi over 4. So when we look at it, this says we actually have the square root of 2 over 2 I plus the square root of 2 over 2 j, which is going to give me a component form of the square root of 2 over 2 square root of 2 over 2. Now with that, I can calculate its magnitude. So this is going to be the square root of that square root of 2 over 2 squared plus the square root of 2 over 2 squared. So with that, we can start to simplify. So when we look at the top, this is going to end up being 2 over 4 plus 2 over 4. In this case, we can reduce that down. So we keep the denominator the same, add across the top. This gives you the square root of 4 over 4, which equals 1. Okay, let's take a look at v. So v is equal to the cosine of 5 pi over 6 I plus the sine of 5 pi over 6 j. Alright, when we look at the cosine of 5 pi over 6, we know that that's going to be on our unit circle. So here's our unit circle. I want 5 pi over 6, which we can find right here, 5 pi over 6. The cosine is going to be the x value, so you can notice here that I've got a very small y value, I've got a large x value, but I've also got my coordinate points here. So this one is going to be negative square root 3 over 2. So the cosine of 5 pi over 6 is going to be negative square roots of 3 over 2. And then in this case, the sine of 5 pi over 6 is going to be 1/2. So I need to plug in the information just like I did before. So this is going to be negative square roots of 3 over 2i plus 1/2 j. So my component form is going to be negative square roots of 3 over 2 and 1/2. And then with that, again, I can find my magnitude. So here, we're going to start by taking the square root. So I have negative square roots of 3 over 2, square it, plus my 1/2, square it. So when I do that, I'm going to end up with 3 over 4 plus 1 over 4, which again is going to give me the square root of 4 over 4, which is 1. Now that I've done everything I need to find my individual pieces, now I gotta do the equation part. So first and foremost, I have that the cosine of my angle again is equal to the dot product over the magnitudes. So in this case, I'm going to end up with the cosine of my angle being the dot product of square root 2 over 2, square root 2 over 2, dot product to the next one, negative square root 3 over 2, 1/2. This whole thing is going to be over my magnitudes, which in this case are going to be 1 times 1. So let's go ahead and work with that dot product piece. So remember, it's going to be the square root of 2 over 2 times negative square roots of 3 over 2, and we're going to add that to the square root of 2 over 2 times 1 over 2, or 1/2. Since the whole thing is over 1, it kind of means that that bottom drops away, and so here we're going to be left with, go straight across the top, negative square root of 6 over 4 plus the square root of 2 over 4, which can also be written as negative 6 square root of 6 plus the square root of 2, the whole thing is over 4. So now we need to take a look at the fact that this is the cosine of my angle. It's going to be negative square root of 6 plus the square root of 2 all over 4. So to find my angle, says I have to take the inverse cosine, negative square root of 6 plus the square root of 2 all over 4. And so in doing so, when you plug it in, you're going to come out with 105 degrees. Now, how do I know if I can leave it here or not? Notice the term in the front says in radians. So that says I have to take this and I need to convert it over to radians. So this is going to be the same thing as 1.8326 radians. Now I want the nearest hundredth. So my actual result is going to be 1.83 radians. And there we go. That is what we needed. Alright, let's take a look at just one more example here. Alright, so here I want to find u dot v where the theta is the angle between u and v. So here I'm giving you the magnitudes and I'm giving you the angle. So all you have to do is find the dot product. What does that mean? Well, it means I know my formula is the cosine of the angle is equal to the dot product over the magnitudes. So you simply have to plug in what you know. Okay, here my angle is pi over 6. So this is going to be the cosine of pi over 6 is equal to u dot v, and my magnitudes were 4 times 64. So I just simply need to solve. So u dot v is going to be 256 cosine of pi over 6. In this case, I know pi over 6, so this is going to be 256 times the square root 3 over 2. We could go ahead and multiply that, and we come out with 128 square roots of 3 is u dot v. And that is what you were looking for based on the information that you had been given. So in a nutshell, that is everything that you would need to be able to get started with working with the dot product, as well as finding the angle between your vectors using the ideas of dot products. So if you have any questions, as always, please let me know. Otherwise, I hope you enjoyed this video, and I look forward to seeing your questions, your comments, any of your concerns, and to seeing you next time.